So once we have this isentropic potential vorticity, which is conserved in adiabatic situations, we can just look at its behavior in bandpass periods like 6 to 30 days, which give you a sense of propagation, which is typically how we do extraction of waves in the full flow that we get from satellites or models or reanalysis and so on. So we are going to look at sections along these in a couple of ways in the isothermal isopotential isentropic surface of 345 and 315 K, and then also in the vertical, which gives you a sense of how the perturbations from the extratropics can move into the tropics. So here is the first example. This is isentropic potential vorticity with lagged correlations on the 345 Kelvin surface. So you take a base grid somewhere here, for example, and then you correlate with the other points with a time lag of time lag of 3 days, and you can see the signal propagating from the northwest towards the southeast right through the westerly duct at lag 0. The correlation looks this way, grown in the deep tropics in the eastern Pacific, which is a well-known region that receives these perturbations, and then at lag plus 3 days with respect to this base grid, you have a penetration right across into the southern hemisphere, going into the extratropics of the southern hemisphere. So that's a clear example of the impact of the full 3D circulation and the westerly duct on the penetration of the extratropical perturbations as seen in the isentropic potential vorticity. If you do the same on the 315K surface, which has these easterlies, then you can clearly see that there is a blocking of this propagation towards the lower latitudes into the other hemisphere, and there is a very weak penetration into the easterly regime, and it doesn't really make it into the deep tropics except around here near the dateline. Okay, so this clearly shows that using this 1-point correlation in the horizontal plane at the upper and lower levels, the impact of the westerly duct in terms of allowing the penetration of the mid-latitude perturbations is very clearly seen. We also want to see, of course, the vertical propagation, which can be done using the same method. But once you have these filtered time series, you can compute the phase speeds of these propagations and so on. This tilting corresponds to the energy propagation combined with the basic flow and so on. So we are not going to go into those details here, but this is how the group speed can be computed in the meridional direction for how the energy is coming in, and you can see the impact of the basic state over there, which is now varying both in the vertical and the horizontal, and that's our zonal phase speed, of course. Okay. Do the 1-point correlation now in the vertical plane. So again, we are going from the southern hemisphere into the northern hemisphere across that diagonal line. The easterly dome can be clearly seen here. Now you are doing 1-point correlation with this base grid. Now you can see the various potential temperature surfaces as well in the pressure coordinate, and you can again see the propagation happening here from the across this diagonal line from the northern hemisphere. You can see the impact of the westerly dome in the vertical as well. The tilting in the vertical plane when they hit the easterly dome is very clearly seen, which is very different in this region where you have westerlies. Okay, so it's kind of a qualitative picture, but it clearly shows the physics and the dynamics of how extratropical perturbations are so clearly able to penetrate the deep tropics and into the other hemisphere through the westerly duct. That's the main point, which we will kind of conclude with the main point we were trying to make. Now looking at 200 hectopascal geopotential shown here as contours and the 345 Kelvin isentropic potential vorticity with the appropriate units, you can see this penetration of positive IPV in the northern hemisphere and the negative IPV in the southern hemisphere. Now you are just looking at the zonal meridional plane, so you can see the penetration into the deep tropics from both sides in the same region that we talked about, the westerly duct region. What you can do is now combine that with the vertical velocities and OLR to see that where there is penetration of PV from higher latitudes, you do end up with low OLRs, especially in this case, and upward vertical velocities, which are of course indications of convection. Okay, so these are specific days, January 14, 15, and in 1987. So this is the, let's say, what are the differences I'm looking at? So just different times. Okay, so clearly you can see that the extratropical perturbations are associated with convective activity in the deep tropics. Doesn't necessarily mean we have answered the question of whether they are triggering the convection, but this correlation is a strong indication that the original idea of Charney, that penetration of extratropical perturbations into the tropics can create baroclinic processes even at the scale of 10 to the 6 meters, which was his main point. Okay. With that, let's make some synthesis of the ideas. Regions of equatorial westerlies in the central, eastern Pacific and the mid-Atlantic, strongest in the boreal winter, are fundamental climatological features of the tropical upper troposphere. Equatorial westerlies possess high-frequency activity and serve as conduits for equatorially propagating Rossby waves. In the Pacific region, during the boreal winter, northwest to southeast oriented storm tracks or teleconnection patterns commence off the east coast of Asia to the west coast of South America and possess a northwest southeast tilt. That's the line through which we saw the results. The extent of the incursion of the extratropical waves into the tropics depends on the sign of the basic state, which we have repeated several times to make sure we get it. And if westerly, on the strength of the upper tropospheric westerlies. So westerlies are favorable, and their strength makes a difference in the near equatorial region, especially in the upper atmosphere. Noting the difference in the equatorial zonal winds between El Nino and La Nina, it may be expected that the incursion may be stronger in the Pacific during La Nina and stronger in the Atlantic during El Nino. So there are shifts in the Walker cell during El Nino and La Nina between the Atlantic and Pacific Oceans. Indian Ocean is unique because of the monsoonal forcing, but that shifts in the upper level westerly duct and the westerly activities can be expected to affect the incursions that we talked about here. The relative scale of the forcing and to the longitude of the westerly duct are also important. The location and the scale of the forcing was important, and as the Rossby waves emerge from the subtropical jet stream, which has lots of meanders and intrinsic nonlinearities, overall their relative impact may be expected to vary from year to year. So how all these ideas can be brought together to explain tropical, like El Nino, La Nina are majorly tropical processes, but they can modulate the extratropical influences. So this feedback has to be understood as well. The vertical structure of the zonal velocity field is complex, with easterlies underlying the westerly maxima. As a consequence, there is a significant vertical variability in the equatorial propagation of waves, with a lower tropospheric part of the wave being retarded by the easterly dome. So the 315 Kelvin isentrope that we saw has mostly easterlies, and in the vertical structure it appears as an easterly dome, which clearly acts as a barrier to the propagation of the extratropical perturbation into the tropical regions. Okay. Before, we had discussed the Charney hypothesis that extratropical disturbances influenced convection at low latitudes. The hypothesis was lacking in two key issues: a mechanism for extratropical waves to propagate to deep tropics, and given the perceived non-divergence of the tropical atmosphere, the near barotropic structure, a mechanism to produce vertical velocity or the baroclinic processes was not described before. The breaking of Rossby waves and their propagation through the westerly duct helps satisfy the first mechanism of this propagation through from the extratropics into low latitudes. The modal listing ahead of the intrusion that we saw creates areas of vertical velocity that would be associated with reduced stability that follows the PV thumb rule that we talked about. So Charney's idea that convection can reduce vertical stability and lead to coupling of the upper and lower levels baroclinic processes does seem to work here, as we saw in terms of the PV intrusion and the correlations with the OLR and vertical velocities. Okay, so it's mostly a qualitative argument, but with correlations with real flow fields. It's clear that this is a very viable link from the extratropics to the tropics. So let's keep that in mind as we go ahead with this physics in more details.